In this lesson, we're going to talk about simplifying algebraic expressions. Now, an algebraic expression is just simply a mathematical sentence that uses the different operations. It has multiplication, addition, subtraction, and division. The one thing it does not have is that it does not have an equal sign. Okay? An expression does not have an equal sign. All right. So the different parts of an algebraic expression are terms, which are sort of like the words or whatever, and then you have the operations, which is adding, subtracting, multiplying, and dividing, and the expressions, okay, are the operations are what divide the terms up into the separate parts. A term can either be a number, a variable, which is a letter, and it can be any letter. Most often we use X or Y, sometimes A, sometimes B and C, or it can be the product of numbers and variables, or which is product means multiplying a number and a letter, okay, or if we divide it like this, okay, which actually is actually a product. And I'll show you that in a minute. Okay, so in this expression here, 7x is a term, 5 is a term, 3y squared is a term, y squared and or y and x divided by 3 are all different terms. All right, and the operations um, are, well, in 7x it's multiplying. Okay, x over 3 is dividing. 3 times y squared, that's multiplying. But the terms are separated by the addition and the subtraction that's in between them. Now the coefficient is a number that's multiplied by the variable in an algebraic expression. So for example, in this first one, 7x, 7 is the coefficient. All right. 3y squared, 3 is the coefficient. All right. And then we'll talk about x over 3. All right. So if you have a variable that's by itself, like y, like right here, it has a coefficient of 1. So y is the same thing as 1y. Well, where that also comes into play is with the x over 3. This would be 1x over 3, which could be written as 1/3 x. All right. So you can see here that this x divided by 3 is the same thing as multiplying x by 1/3. So that's where this also comes into play, and how multiplication is involved in the division problem here. So make sure that you understand these definitions. You understand what terms are. You understand what coefficients are, so that when I talk about a term or talk about a coefficient, you know what I'm talking about. When we simplify algebraic expressions, we collect the like terms. Well, like terms are terms that have the same variables raised to the same power or to the same exponent. The coefficients, the numbers in the front, do not have to be the same. Okay? And the numbers that are called numbers, like just regular numbers, are called constants. They're like 5, 1/2, 3.2. Just a regular number without any variable behind it. Okay, so like terms here, you have a 3x and a 2x are like terms. They both have the variable x, okay, and it's not raised to a power. Not y, w and w over 7. Well, you have the same variable, w, raised to the same power. and then you have 5 and 1.8. Well, those are the constants. Okay, so that's a constant, right? And all that. Now, terms that are not alike or unlike terms are 5x squared and 2x. Well, if you look here, that x is raised to the second power. This one is not. Okay, so that means that the exponents are different. That's why they're not like terms. 6a, 6b. Even though the coefficients are the same, it doesn't matter because the variables are different. All right, one's an a variable, one's a b variable. And then 3.2 and n, well, one's a constant, 3.2 is a constant, and n is a variable. So there's no variable over here in 3.2. All right, so it says identify the like terms. And one of the things that is useful if we're identifying like terms is um, if we use different ways of identifying it. So one way would be by I could use different colors, okay, but when you're doing it on paper, you're not going to be able to use different colors. So I could use different shapes, okay. So here we have a 3T. I'm going to draw a box around 3T. And if I look over here, okay, so I got to pay attention to the T. And I want to look at all the other terms that have a T variable in it. Well, W squared, nope, that's not it. 7T. Well, yeah, there we go. That's another one with a T term in it, so I draw a box around it. 9V, nope. W squared, nope. And 8V, no. So the only ones that are like terms in this list with the T's are the 3T and the 7T. Well, let's go to the next one. W squared, 5W squared. I'm going to draw a circle around that one. Okay, 5W squared. Okay, so let's look at the other W squareds. Well, we've already used the T, so it's not that. 9V, no. And 4W squared, yes. Okay, so draw a circle around that. So those are like terms. And then, obviously, you have a 9V and an 8V. I'm going to draw a triangle around those. Okay, and you can use whatever shapes that you want to use um, to differentiate between the two. So I have a 9V and an 8V. They'll both have the V variable. Okay, so in your classwork, what you're going to want to do is you're going to want to write 3T and 7T, put a comma, 5W squared and 4W squared, put a comma, and 9V and 8V. Right. So, and if you want to somehow differentiate that 3T and 7T go together, 5W squared and 4W squared go together, and 9V and 8V go together. Or they're not going to be those actual numbers, but whatever the numbers are. Okay. Next step: identify like terms. All right. So I'm going to go through this a bit quicker because we should already know how to do it. So that has an X term. So we have a 2X. I'm going to draw a box. And then I look down through here, I have an 8x, and there's no other x term. So we have 2x and 8x, okay? Then I can draw actually a semicolon if I want to. Then I have 4y cubed and 5y cubed, okay? So 4y cubed, comma, 5y cubed. All right, semicolon, and then 5z and 8z. All right, so those are the like terms. So when we simplify, we're going to just combine the like terms. Okay, so here obviously it's a t and a t, a 6t and a 4t. Our operation is subtraction. So we're just going to say 6t minus 4t. We're going to subtract the coefficients. Okay, 6 minus 4 is 2t. It's that easy. All right? All you do is, if the terms are like terms, you either add or subtract whatever the operation is, the coefficients. All right. So here, 45x. All right. Well, that's a y and that's a constant. Oh, well, there is no other x. All right. Minus 37y. Well, that's an x and that's a constant. There is no other y. And 87, that's a constant. There are no other constants. So we can say that this is already simplified. All right, I misspelled simplified, but all right. Next one. Now this one looks really complicated, but it's not that complicated. Okay, so 3a squared, 3a squared. So I'm going to circle that. And b, no. B squared, no. B, no. Ah, here's another a squared. So I'm going to circle that, but I'm also going to circle the operation. Okay. So I have 3a squared plus 2a squared. So if I combine those, I end up with 5a squared. I'm going to add them because it's a plus. Okay. The next one, I have a 5b. We have 11b squared. No. I have a minus 4b. All right, so what we're going to do here, we're going to say 5b minus the 4b. All right, 5b minus the 4b, because we're subtracting. 5 minus 4 is 1, and it's a positive one, so we're going to say plus 1b. All right, and then we're going to say 11b squared. Well, if I look, the only thing that's left is the 6. It's not a b squared. So I'm just going to bring, there's nothing to combine it with. So I'm going to say plus 11b squared. Okay. So I'm going to just do that. And then I have the minus 6, because there's nothing to combine it with. Now, the only additional thing that I would need to do here is this right here. I don't need to have a 1 there. So I could just rewrite this as 5a squared plus b plus 11b squared minus 6. All right, so you normally, that 1 is understood to be there. You don't have to write it down. All right. Next example. Well, this is another one where it's just the two terms, a y and a y. 5 plus 3 is 8, so that's 8y. Okay, this one we have an x squared, and we have an x squared here. So I'm gonna circle that with the plus sign there. Here's another x squared. Well, how about that? Okay, so we have actually 3 terms that we can combine. Okay, so we have 4x squared plus 3x squared, which is 7x squared, plus another 2x squared. So we have the x squareds here. Okay, x squareds. We have 4 plus. Well, hang on. Let me redo this. I can have 4 plus 3 plus 2 x squared. All right, which is 4 plus 3 plus 2 is 9x squared. And then the y's, we have a positive 4y minus 4y. Okay, so let's see here. We're going to say plus. We're always going to start off with plus. And so then our coefficients here are 4 minus 4 y. 4 minus 4y. 4 minus 4 is just simply 0y. And then the only thing we have left here is a plus 5. All right. So what this means is that 0 times anything is going to be 0. All right. So we can just eliminate it, and our answer would be 9x squared plus 5. All right. All right. So this is write an expression for the perimeter of the triangle. Perimeter is a distance around. So this would be the sum of the sides. All right, the sum of the sides. So that means you add all the sides together. So we're going to say 2x plus 3, that's the first one, plus 3x plus 2, plus just an x. All right. So now the only reason I drew the parentheses around there was to show that they're the different sides. We don't really need them. So we can say 2x plus 3 plus 3x plus 2 plus x. Remember this x here. Remember that x here, the coefficient of that is a 1. All right? So when we have our x's, when we combine our x here and here and here, we're going to say 2 plus 3 plus 1 x. All right? So that's this and this and this. All right? And they're all pluses. Okay? And then we're going to say plus, and then we're going to add our constants, which are 3 plus 2. That's here and here. All right, so 2 plus 3 plus 1 is 6x plus 3 plus 2 is 5. So the simplified expression for the perimeter of this particular triangle is 6x plus 5. All right, last example. The same thing, write an expression for the perimeter of the triangle, then simplify it. Remember, perimeter is the distance around it. So I'm going to say, I'm not going to use the parentheses, I'm just going to say 2x plus 1, that's this one, plus the next one, which is also 2x plus 1, okay? And then plus an x, all right? So this is side 1, side 2, and side 3. All right. So we're going to add these. So we have a 2x and a 2x and a x, which remember it has a coefficient of 1. Okay. So we're going to say these are all adding. So we're going to say 2 plus 2 plus 1. That's here, here, and here. X plus, and then our constants are just simply 1 and 1. So 1 plus 1. 2 plus 2 plus 1 is 5x, plus 1 plus 1 is 2. Okay, so that does it for the simplifying algebraic expressions. If you have any questions, make sure you ask, and I will talk to y'all later on.